Now, we have Romel Vázquez with GeoVisual Analytics with gvSIG.
Buenas tardes a todos. He venido de...
Good afternoon. I came from Cuba to present the thesis, my PhD thesis in the University of Granada, and I would like to thank the gvSIG Association for allowing me to present this paper here. I call this presentation data analysis, and the presentation is divided into motivation and introduction. After I'll speak about scientific display, geographical information systems, how exploratory analysis of data was used in order to integrate scientific display with other geographical information systems for the exploratory analysis of data that was done with exploratory analysis of data with high and low spatial density. And also I'll present some tools for the support of some formats of files. The analysis of temporary sequences of data in the form of regular grids is a challenge. Those data usually contain information in the spatial field and represent measurements of many variables. There are different problems that have to be solved in order to analyze large sets of data with all this information in a consistent and effective way. Most of the methods and tools do not allow an effective space and time analysis of the multiple variables simultaneously. This work treats the problem of the visual analysis of time sequences of multiple variables with low and high spatial density. We have different cases, study cases that show the effectiveness of those methods. The problem mainly is that the analysis of time series, which are spatially distributed, is difficult when different variables are analyzed simultaneously. We are used to work with a single variable with which we can process time series in the present systems for geographical information. So then we did the integration of scientific display techniques with geographical information systems in order to facilitate the solution of this problem. The main advantage of using those techniques is to do comparisons and be able to do comparisons, identify patterns, correlations, detect abnormalities in large volumes of data. Which is the idea? A scientific display transforms scientific data, abstract data, into images and classifies the techniques of scientific visualization in visualization, display techniques for volumetric data, display techniques for fluids, display techniques for multiparametric data, and display techniques for information. That has been done with multiparametric data. The multiparametric data consists on a number of registers where each one is defined by a vector having n values. This data can be displayed as a matrix m by n, where each column represents a register and each line represents a variable or a dimension. We are speaking about techniques which are geometric, based on icons, based on pixels, and others. Others can be based on axes, and others can be useful for the representation of data and the reduction of dimensions. In multi-parametrical data, among the geometrical technique, we have matrices, which is the one that you have on image number A. Then we have parallel coordinates where the different axes represent the different variables, and the data are lines that go from one variable to the value on another variable. In this case, the data should be standardized between 0 and 1 in order to find the correlation between data, and the full lines are lines that can take us to different conclusions. We can restructure and move different dimensions in order to find better correlation between data. We have other techniques like Andrew draws. And here we have a kind of matrix where we represent each variable as a column and the elements as a line, which has a color on it. And when you see time register, then you can see the distribution that you obtain along the time. Yeah, and it's much easier to appreciate than if you use a number. Here you have the star coordinates, which is very similar to parallel coordinates, drawing lines from the value in one of the variables to the value in another variable. We have other techniques based on icons. This can be used in order to code using some icons. This is called the channel phase and can be used for psychological variables, as some of the variables can be coded based on the size of the head or the eyes or the eyebrows. And in this case, this is sociology, and you can show that on maps in order to see the population in an area. We have star fields where we have this visualized as stars. And you can see the trend in some of the data. We have the bar charts. We have color icons. You can use color coding for a better representation. And one of the most widely spread are techniques based on pixels. Here we have the squares and the circles. The idea of the techniques based on pixels is using the unit visualization, the display unit as a pixel. And we can use recursivity patterns and that means that the technician should know how this information is structured in order to be able to define the pattern so that this can contribute information that cannot be extracted just if you see the numbers and the figures. This is a circle method that uses pixel units in each one of the variables, in each one of these segments. We have elements. They are very useful for large volumes of data. We also have other techniques, like the one which is based on axis, like the time wheel, where we have this line here that proves the time variable, that shows the time variable, and the remaining variables are around throwing lines based on the value of that variable, and then towards the time in which that was taken. Here we have also a time scale. This is like a simple time graph, but this is circular with multiple variables and can be viewed on a map, can be displayed on a map, and others can be also used, like the self-organizing maps that map 10 variables in order 2 dimensions, where each one of those circles represents the clusters or groups detected from the full set of data. These circles represent the quantity of elements or clusters that belong. The size represents the quantity of elements that represent to that point. Using the technique, the background, the black background means that those clusters which are separated by a black background, that means that there is a high difference between them, while those which are on a white background are closed with each other. Are close to each other, excuse me. And we also have geographical information system, and we were using different system, ArcGIS, GrassGIS, QuantumGIS, gvSIG, OpenJump, UDIC, Sextante, and all the algorithms were implemented on gvSIG and Sextante. Speaking about the exploratory analysis of data, this is a subject that was originated by statistics. That was one of the initial origins of statistics, finding patterns, for instance, or describing patterns, trends, and relationships between data, and it's more related to the generation of hypotheses that with the demonstration of hypothesis. And we have an exploratory analysis of data that can be a study from the point of view of data and from other points of view. And this trend of integration between geographical information system and scientific visualization is around for many years. In the 2000, in the decade of the 2000, they were in development, and for instance, the display systems had some difficulties to incorporate the formats of the geographic data, but they were very strong in the handling of scientific data formats. And that's the reason why, since 1997, Dr. Maria Teresa Rijn was speaking about 4 integration methods between both disciplines. One is rudimentary, operational, functional, and mix that incorporate both technologies largely. There were many different attempts for integration between these tools. We have, as an example, a snap together visualization, GeoVista Studio, VisStamp, JV Flash Tools, ArcView, XGobi. But after we used them, we draw some conclusions. For instance, they were not incorporating a format for scientific data. Some of them were not incorporating large quantities of techniques in gvSIG. Some of them do not allow the complete handling of its components, or they cannot form a raster map. Another integration example are the main formats of scientific data, like hierarchical data format, Earth observing system, which is largely used, common data format. They allow simple models, good use of metadata, good handling of large quantities of data, and we think that the scientific formats can be very useful and can be integrated in the geographical information systems. We created a model in order to integrate the scientific visualization techniques, and this model was used for a problem, in this case, for data with low spatial density. For instance, data related with meteorological stations, which can have many variables at the time, measured in different moments of time. Also, data taken from census in regions, municipalities, provinces, countries. And we say that when we have a low level of data sets, sometimes they can contain many variables at the same time. And this is the case. We also use gvSIG for the vectorial layer display and a series of techniques in order to have access to vectorial data and multi-parametric data. The low spatial density was processed with gvSIG, the Spanish version, open source, free, modular, and easy to extend. And we use the Andrews graphs star icons, shape coding, and segments of circles. Multiparametric data in flat formats like ARFF and DBF were transformed into layers, gvSIG, and vectorial data were transferred in vectorial form. Finally, in this case, we had a tool that allowed to link in either in display or independently a set of n variables that could be displayed for very few regions. And we could find interactions and draw conclusions and relationships between the different variables along the time, taking also into account the spatial reference. In this case, with a recursive pattern, we did a study case that was published by a journal, which is the Anuario do Instituto de Geociencias de Rio de Janeiro. And in this case, the study was presented here in Valencia a few years ago in the International Conference on Knowledge Discovery and Information Retrieval. And in the case of high spatial density, with the development of aeronautics, some companies and organizations at a global level have started to deploy data, large volumes of data. For instance, the climate unit of the United Kingdom, and that has brought about some problems. For instance, we cannot analyze with simple images, as I mentioned. We can have overlapping of different variables, and you can only analyze one variable at a time. And this overlapping help to analyze multiple variables with those methods without having those problems of overlapping, and allowed us to handle different variables at a time. So that originated a new method for the display of time series of variable, multivariable, by means of the use of display techniques of multiparametric data integrated in geographical information system. And we have different study cases where we can show the effectiveness of the techniques. And an example is the CRU that has a resolution of 0.5 degrees at a global level, and represents a time series from 1901 to 2012. And we have different variables like pressure, humidity, transpiration, evaporation, and dew. There are so many things. In this case, we had a core of geographical information. We use the capabilities they have for the raster map display, and we incorporated a scientific display module and a module for the handling of scientific data. The application allows you to select the display techniques that you can use, that the user wants to use in each case, with a preparation of the display techniques, and then it can interact with different locations in the space, and can choose between different techniques and areas in the space where you can consult the data to do a visual analysis. Whenever you do a selection, the data can be loaded on a scientific format. Our own data format was created in HDF, and we had a digital elevations model, which is distributed by the unit for climatic monitoring, and the data set shows the background. And this data set incorporates data sets in each one of the cells with a resolution of 0.5 degrees. So this is a grid of 25 by 25 kilometers, and we have 10 variables taken in the whole planet globally from those variables, humidity, temperature, and so on. This is a data set in format HDF5, and support was provided in order to multiply the techniques and apply different techniques in this format of data that we generated based on the data that is distributed by the unit for climatic research. And then we studied different data focusing on Cuba, focusing on Spain. We have different climate experts of the University of Seville, and we draw some interesting conclusions. These results were published in the paper Exploratory Data Analysis through the Integration of Visualization Techniques in Geographical Information Systems. This is a journal from Venezuela in this case. We develop a set of tools for the handling of scientific data formats that complement this module for scientific display that can work with a large volume of data. Tools were developed for HDF and NetCDF that were the formats selected for the incorporation in gvSIG. They were incorporated into gvSIG and the Sextant library, and the HDF Java and other libraries were added that allow us access to data in formats with algorithms that allow us to transform HDF data into NetCDF format data. Others that allow you to convert the format given by the Unit for Climate Research in United Kingdom into SDF to our own HDF that we have generated in order to be able to analyze this large volume of information. Another very important aspect is the graph modeler of Sextante, and we can integrate and generate model, which is one of the trends of the geographical information systems in order to automatize the handling process, the processing of data. And we generated a data set in the Iberian Peninsula. And our conclusions were that we created gvSIG tools that allow the discovery of pattern trends and abnormalities and relationships between data. The tools include display modules, scientific display modules, and modules for the handling of scientific data format such as HDF and NetCDF. And we could check by case study the performance of those tools.
Right, thanks very much to the three speakers. Now we're going to have a round of questions. Should anybody want to ask any questions? Well, you've been so good. You've explained everything totally, perfectly well. Hi, Roman, for Roman. The tools which are developed on is Punto 0.9.1, which version of gvSIG? The first tool which developed is implemented over 0.9, SVSIG 0.9. With great volumes of data, VHF, manipulation of scientific like VHF, etc., based or on 1.2 version, and it incorporates also 1.2. No. We haven't got it into 2.0 yet. Mainly because, well, partly because from Cuba, things got a little bit difficult to get to access version 2.0, and I didn't. It wasn't available to me, for example. Well, anyway, from versions 2.x, and it was a research work, not the type of work which is carried out to provide support for the system, but didn't really matter that we did it with 2.1 or with 2. Whatever x. But in any case, the open code for the legends, etc., the source code, and the graphs, etc., and all of that. Do you have this published anywhere? Is it published anywhere? At the present, no, it isn't published. No. We've made a register, we recorded it at Land Registry in Cuba. We've done a CAD, but it will be published, yes. And finally, have you NetCDF? I've worked with data, and then things got difficult because there were little submarines which were getting pressurized. So all the series of data that were picked up, their mobile starts to move, and it was difficult to represent. So what I want to try to say is, the MFS, they use a lot of these type of problems. Have you tried with the standard of sensors survey? Sorry, with what? Open the SOS, sensor observation sen. With SOS, we tried it. We did a pilot project, but it was really hard to do, difficult, and I'm not sure if it's being used, anywhere. Well, I'm not. I've got understanding or knowledge of 2.x versions developed with some support for SN NSF in this case. I've been trying it, but actually we haven't used any standard. To be absolutely true, no. To be absolutely honest. Do we have any other questions here? Or not? No? Right, well. Many thanks to the speakers. And we're just going to finalize this session. In fact, we are going to be extremely punctual for the next session to now start.